Hello students, in the previous class we had learnt about the L'Hospital rule of type 3 and we have known the working rule, how to solve if we have 0 into infinity form or my infinity minus infinity form. Today let's learn few more problems on this. See, observe this problem. The given problem is limit x tends to 0, x log tan x you have, and here by seeing the problem itself you can say that it is 0 into infinity form since you have product, and when you apply the limit for this, what it will be, the value of x will be 0 and log tan 0. So this implies 0 into log tan 0 is 0, so 0 into log 0 is minus infinity. So the given problem is in the form of 0 into infinity. Limit x tends to 0, x log tan x is in the form of 0 into minus infinity form. So when you have 0 into minus infinity form, what do? You have to convert it either into 0 by 0 form or infinity by infinity form. So for our convenience, this what we'll do is we'll convert this given problem into infinity by infinity form. So log tan x is here g of x, here this is g of x and x is f of x. As you all know, when g of x is kept as it is and when f of x is brought in the denominator, you'll get the 0 into infinity form changes to infinity by infinity form. So here g of x, that is log tan x, is kept as it is, f of x, that is x, is brought here in the denominator. When x is brought in the denominator, x becomes 1 divided by x. X becomes 1 divided by x in the denominator. So now this is in the form of infinity by infinity form. How? In the sense, log, just apply the limit log tan 0 divided by 1 by 0. So log tan 0 is in minus infinity by 1 by 0 is infinity. So you have this in the form of infinity by infinity form. Next, when you get the infinity by infinity form, you can apply L'Hospital rule. So L'Hospital rule says that you have to differentiate the numerator and denominator separately. Log tan x differentiation is 1 by tan x. Tan x differentiation is secant square x and divided by, into the denominator you have 1 by x. 1 by x differentiation is minus 1 by x square. So here limit x tends to 0, secant square x by tan x into minus x square. Then here limit x tends to 0. As you all know that tan x, limit x tends to 0, tan x by x value is 1. So we'll rearrange this term. So how do you rearrange? You can, so first I'll split this two terms separately according to our convenience. So minus x square is written as minus x into secant square x into x divided by tan x. So now we have splitted this one term into two terms. So what is that? So minus x secant square into tan x. So now we apply the limit for both the terms. It becomes limit x tends to 0 minus x secant square x into, apply the limit for this also, limit x tends to 0. We can write this as 1 divided by tan x divided by 1 by x. So it becomes, so divided by x, tan x divided by x. Limit x tends to 0, 1 divided by tan x divided by x. Since we know that limit x tends to 0, 1 divided by tan x divided by x value is 1. So now this whole term becomes 1. So here you have limit x tends to 0 minus x secant square x into 1. So here now apply the limit for this, minus into 0 secant square 0. So 0 into secant square 0 is 1, 0 into 1 is 0. So here limit x tends to 0, x log tan x is in the form of 0 into infinity form. Then you convert it into infinity by infinity form. How do you get this infinity by infinity form? G of x, that is log 10x, tan x is kept as it is in the numerator, and then f of x, that is x is brought in the denominator. When x is brought in the denominator, so it becomes, when f of x is brought in the denominator, it will get infinity by infinity form. So when you get the, as soon as you get the infinity by infinity form, apply the L'Hospital rule. The L'Hospital rule says that you have to differentiate the numerator log tan x separately and 1 by x, which is in the denominator, separately. Again you have to apply the limit. Again you can rearrange the terms here. After rearranging the terms, this term becomes, the value of this term becomes 1. And when you substitute the limit for this minus x secant square x term, the answer you'll get as finite value, that is 0. Now let us, and you have to write the second problem, limit x tends to 0 x log tan x, in your record. First problem and the second problem should be written in your record. Now let us solve one more problem, that is limit x tends to infinity a power 1 by x minus 1 into x. So the solution, so look at the problem, this is into the form of 0 into infinity form. So you can write as limit x tends to infinity a power 1 by x minus 1 into x, which is in the form of 0 into infinity form. So here look at this problem. Here the value of x is infinity into a power 1 by x minus value 1 a power 1 by x minus 1 value is 0. So you have 0 into infinity form. So this is in the a power 1 by x minus 1 x into x is in the form of 0 into infinity form. Just you can cross check here, like a power here, the observe here the x tends to infinity, the limit you have x tends to infinity a power 1 by infinity minus 1 into infinity. So what you will get, a power 1 by infinity is a power 0, then minus 1 into infinity, a power 0 is 1, 1 minus 1 into infinity, 1 minus 1 is 0. You have this given function in the form of a power 0 into infinity form. So then again we have to convert this 0 into infinity form in the form of either 0 by 0 form or infinity by infinity form. So what we'll get here, so we'll convert limit x tends to 0 a power 1 by x minus 1 is kept as it is, and this x is brought in the denominator. When x gets in the denominator, what you'll get, x becomes 1 by x. So now what I'll do here, for my convenience, I'll change the value of 1 by x here, the power 1 by x, and denominator also you have 1 by x. So what I'll do, replace a 1 by x by t, as x tends to infinity, t equals, what happens when here the limit is x tends to infinity, when x tends to infinity the value of t also changes, 1 by infinity. So 1 by infinity is 0. So here limit x tends to infinity changes to t tends to 0, a to the power of t minus 1 divided by t. So this is in the form of a to the power of 0 is, so a to the power of 0 is a to the power of 0 minus 1 divided by 0. So a to the power of 0 is 1, 1 minus 1 by 0. This is in the form of 0 by 0 form. So here limit t tends to 0, a to the power of t minus 1 by t is in the form of 0 by 0 form. Remember here why we are here, that you don't have the limit as x tends to 0. Instead of x tends to 0, you have x tends to infinity, and you have power as 1 by x in the form of fractions you have. So whenever, as usually whenever you have the powers in terms of fraction, you replace it by one term, right? T is equals to 1 by x. So we have replaced this 1 by x by t, and when you replace this t by 1 by x by t, here even the limit also changes. Hence the x tends to infinity changes to t tends to 0. So here, since it is in the form of 0 by 0 form, you can apply L'Hospital rule, carry the limit as it is, 8 power t differentiation is a power t into log a, 1 differentiation is 0, t differentiation is 1. Substitute the value of limit a to the power of 0 into log a, the answer is log a. So here limit x tends to infinity, a to the power of 1 by x minus 1 into x. Answer is log a. Let us solve one more problem related to this, that is limit x tends to pi by 2 into secant x minus tan x. So here limit x tends to solution, the solution is limit x tends to pi by 2. So here secant x minus tan x is in the form of infinity minus infinity, right? Secant pi by 2 is infinity, tan pi by 2 is infinity. So infinity minus infinity. Let's write the given problem. Limit x tends to pi by 2, x tends to pi by 2, secant x minus tan x is in the form of infinity minus infinity form. So next, after writing this infinity by infinity form, so what you have to do, you have to convert this f of x and g of x, this is your f of x and g of x, into the fraction form. That is 1 by secant x can be written as cos x minus tan x can be written as cos x by sin x. Sin x by cos x. Now you can take LCM, since both the terms are in the form of fractions. You can take LCM, x tends to pi by 2. So the LCM is cos x, here 1 minus sin x. So apply the limit here. What you will get when you apply the limit pi by 2? 1 minus sin pi by 2 divided by cos pi by 2. So 1 minus sin pi by 2 is 1, cos pi by 2 is 0, 0 by 0 form. This is in the form of 0 by 0 form. Next, when you have 0 by 0 form, you can apply the limit. So differentiate the numerator separately, denominator separately. Differentiation of, carry the limit as it is, limit x tends to pi by 2. When you differentiate the numerator and denominator separately, remember, don't forget to carry the limit as it is. Differentiation you have to do separately, but limit should be carried out. So differentiation of 1 is 0, sin x differentiation is cos x, and cos x differentiation is minus sin x. Apply the limit, minus cos pi by 2, cos. So you can directly, or you can write limit x tends to pi by 2. This minus can cancel. Cos x by sin x is cot x. So here cot pi by 2 value is 0. When you apply the limit to this cot x, that is, you will get as cot pi by 2. Cot pi by 2 value is 0. Now let us solve one more problem here. That is limit x tends to pi by 2, 2x tan x minus pi secant x. Here clearly you can say that it is in the form of infinity minus infinity. So this is in the form of infinity minus infinity. So let's write that given problem is limit x tends to pi by 2 is, that is 2x tan x minus pi secant x is in the form of infinity minus infinity form. So you have to brought it into the 0 by 0 form or infinity by infinity. So first you have to do, you have to bring it to the form of 1 by f of x. So 2x as it is, tan x can be written as sin x by cos x minus pi secant x can be written as 1 by cos x. So here now you have two terms which is in the form of fractions. When you have fractions, when you have difference of two fractions, you can take the LCM. So LCM is cos x, here numerator it will be 2x sin x minus pi. So here apply the limit here, 2 into pi by 2 sin pi by 2 minus pi, you will get the answer as 0 by 0 form. Both are in the form of 0 by, cos pi by 2 is 0, sin pi by 2 is, like when you substitute the value, both the values will get as 0 by 0 form. So here limit x tends to pi by 2. So here after, when you get 0 by 0 form, you have to apply the L'Hospital rule. So you have to separate, differentiate the numerator and denominator separately. The differentiation of numerator is, since you have product rule, 2 is constant here, first term into differentiation of second, first term as it is, differentiation of second term is cos x plus second term, that is sin x, differentiation of x is 1, differentiation of this pi is 0. cos x differentiation is minus sin x. So limit x tends to pi by 2 as it is. So what happens here? 2x cos x plus 2 sin x divided by minus sin x. When you apply the limit pi by 2 as it is, you will get the first term as 0 plus second term will be your 2 divided by minus 1. So answer will be minus 2. Hence the proof.